Hi, it's Paul Anderson, and this is Science and Engineering Practice 3, Planning and Carrying Out Investigations. Investigations are incredibly important in both science and engineering. We use them in science to answer questions that we hopefully have developed on our own. And in engineering, we use it to test designs that we've created. And so investigations are important, but what comes out of an investigation is going to be data that we can then analyze and use to reformulate new questions or reformulate theories. And so when we're thinking about carrying out investigations, the idea of a science lab and doing science experiments brings up images like this of a person working in a chemistry lab or a physics lab, gathering data, designing an experiment, and then they're testing out that experiment. And that's a huge part of science and engineering. But know this, that there are a lot of science that we do just through observations. And so if you're studying ecology, this is an ecological study using a quadrant right here, you're going to do that by watching, not designing experiments, but observing the Earth and the world and the way it works. And so astronomy is going to be an observational science. Or this right here is Jane Goodall working with some students, doing some ecological studies or geology. We're getting out there and actually making observations. Doesn't mean that these are not important. They're just as important as the science investigations that we do. They're a big part of science. And so not all science is the scientific method of, develop a hypothesis and go through all that. It's a big part of it, but know that observational science is also important. But when you're planning an observation, there are really 3 steps you want to go through. Developing a good question, coming up with the variables, and then coming up with the controls. And so let me step you through that. Let's say I am observing a pendulum, and I'm just watching a pendulum swing back and forth, and I'm trying to come up with a good question. Now, this is a virtual pendulum, so it will never stop. But a good question I might come up with is related to the period. The period is how long it takes for the pendulum to complete one cycle. So from here, so about 3 seconds, it sounds like. So it's about 3 seconds to go through one period. And so maybe that's going to be the factor that I want to study. So initially my question might be, what factors affect the period of a pendulum? We then move on to the variables. And so what could affect the period of a pendulum? And I want to brainstorm as many ideas as I can come up with. Maybe it's going to be the length of the pendulum, how far it is from the pivot point. Maybe the mass of the pendulum is going to affect the period. It could be the amplitude. In other words, what is that angle away from just vertical? Maybe gravity is going to affect it, or air drag, or there could be a number of different things that are going to affect it. But I want to come up with one good one that I think I could vary. And so let me choose, for example, shape would be good as well. Let me choose amplitude. And so I'm going to measure how the amplitude, how high I release the pendulum is going to affect the period. But I'm going to hold on to all these other variables, and they'll come in just a second. And so basically what I can do is I can now use those 2 variables, amplitude and period, to come up with a good question or to refine my question. Because in a good scientific investigation, we really only want to vary one thing and measure another. And so I'm going to say amplitude and period are going to be my variables. All those other variables now become controls, things that I'm going to have to keep the same in the experiment. And so that is going to have the same shape. It's going to have the same amount of air. I would have a hard time changing gravity, but it's going to have the same gravity, mass, length. I really want to come up with, 8 to 10 things. Maybe how I'm going to time it has to stay the same, or the way I release the pendulum has to be the same, or the pivot point and what it is and how it's made has to be the same. So I'm going to keep everything else the same in my investigation, except the thing that I'm going to vary, amplitude, and the thing that I'm going to measure, and that's going to be the period. And so you want to control everything else in a scientific experiment. If you don't, you're just going to get bad data. Okay, once I've done that, I'm going to create a data table where I've got my amplitude and my period. Now, the amplitude is what we call an independent variable. In an experiment, I am changing the amplitude, how high I drop it from, and so that's going to be the independent variable. The other variable then becomes the dependent variable. So the period is going to depend on the amplitude. And again, I vary this one, and this is going to be varied. And in general in science, we put amplitude, or excuse me, the independent variable is going to be in the first column, and then the dependent is going to be in the second. And so let me start collecting some data. So now we've got an amplitude of 135 degrees. I could time it, so like that, and I could figure out how long the period is. When I did this earlier, I found it was about 3.4 seconds. How did I do that? Well, the first time I started doing it, I simply started a stopwatch and timed how long it took to go back and forth. But it seemed not very precise. And so what I ended up doing was letting it swing back and forth 10 times, and I could get better data. If we move to 120 degrees and I let the pendulum swing, that ends up with a period that's going to be less. 3.1 seconds is what I got. Or 90 degrees, it's going to be even less. Okay, so what am I doing? I'm collecting data now in my investigation. I can analyze that, but we'll get to that in the next practice. And so when you're carrying out investigations, there's a few things that you definitely want to talk about. One is accuracy and precision. And so accuracy is how close am I to the right answer? And so on this graph right here, if this is the right answer, maybe the right answer was, for the first one, was 3.3 seconds. If I'm close to that, then I'm accurate, or my answer is close to the correct answer. Precision looks at all the data that I collect. In other words, this is a good analogy. Let's say I were to do that 4 times and I were to get these values. Well, they're going to be pretty accurate. They're pretty close to the right answer, but they're not precise. And so if we were to look at this one, these would be very precise answers. I do it over and over and over again, and I get answers that are very close to each other, but they're not close to the right answer, and so they're not accurate. And so accuracy, are you correct? Precise, is your data grouping together correctly? And so it's really important that you repeat the experiment over and over and over again until you get data that's very, very good, accurate, and precise, because we want to be right here in the middle of that target. Sample size is very important then. Sample size is how much data did you actually collect? If you were to flip a coin and get heads, would you say, every time I flip a coin, I'm going to get heads? Well, no, you know that you're going to get tails some of the time. But if you only do one trial, you're really doing that. You're really just flipping the coin once. And so you want to flip the coin over and over and over and over again. And so if I were to do that pendulum experiment, don't just do it once, but do it multiple times. Get lots of data. Get an increased sample size, and you're going to get better data. What is the goal then through our science classrooms in relation to investigations? You want to be able to plan investigations, starting with a good question and then controlling your variables. Then you want to carry out that investigation, get good data, and you want to make sure you iterate, that you do it over and over and over again. And so let's kind of talk about the progression. So through education, from elementary through high school, how do you start by doing investigations and then get better and better and better over time? And so you start by starting with a question. So you start with a good question. You may want to give students quite a bit of scaffolding. And so in an elementary classroom, a really good lab could be, let's let a ball roll down a plane and then see what can we do to change the speed. In other words, if we change the angle, is that going to change the speed? If we change the weight of the ball, if we change the material that it's made up of? So starting with a question that you give your students is a good way to get them headed in the right direction. As they become older and older and older, we want them to start controlling more of the variables. And so making sure that they're designing the experiment. And so the best way to have your students really understand what a control variable is, what a dependent variable to do, is to just have them do it. And what they're going to find is that in a lot of labs, they're going to get bad data. And you have to allow them to try it again and again and again before they're going to get better at designing. Next, we want to make sure that we're getting good data. Remember, in science, we use that data to reformulate theories again. And in engineering, a good way to make sure your students are getting good data is through competition. So this is like a Lego challenge right here where robots are competing. In my own class, we did this Lego sumo competition. And it was a great way to See how good your data fits against other data by just competition through design. And then finally, you want to let students iterate. You want to let them try over and over and over again. And scaffolding is a word that works really well here. And so there are just a few parts of good investigations. And when students are younger, you want to give them as much of that scaffolding as you can. But as they get older and older and older, you want to kind of let them loose. Let them do science on their own. It's sometimes a little bit scary. It's going to take a little bit more time to do investigations in your class, but the students are going to learn so much more if you can progress that way. And I hope that was helpful.